Okay, a little bit more about the uniform distribution, sometimes called the rectangular distribution, and what we're doing in this first bit of the lesson only applies to that. So we've been looking at continuous random variables. This is just one sort of specific bit of it. So the uniform rectangular distribution, it's a freehand sketch. If we sketch it, it looks like a rectangle. Okay, we have x along the bottom, f of x going up the top. Somebody over there just said the area would equal 1. Yes, it will. Let's say it exists between A and B. If the area is going to be 1, what will this height up here be? Yeah, 1. It's the difference between these two. So B minus A, 1 over B minus A. We just do the big one, take away the small one. So yeah, okay. So what we've got here, the width of that, from there to there, is B minus A. That's the width. The height is 1 over B minus A. That's the height. And if we times those together, we should get 1. I may need to put some brackets in here. If I times those together, that will cancel with that, and I will get the area of 1, so that works. So that's the graphical representation of the rectangular distribution. And what I want to look at next is what the mean is. Now we've had a formula for the mean of a continuous random variable so far. Can anybody tell me how we would go about finding the mean from what we've had done so far of any continuous random variable?
Integrate so it equals 0.5.
That's the median one. The median one is the integrating, so it's 0.5. The mean involves integrating. What do we integrate for the mean? It's not just the function, there's something else in there. Yes, x times by the function. But for this distribution, there's a quick way of doing it. What is the mean of that distribution? Just from looking at it and using common sense. What's the mean? And if you're not going to give it to me in algebra, just give it to me in a wordy description. What would the mean be? B minus A over 2.
A plus B over 2.
A plus B over 2. What are you trying to get to in words rather than algebra? The middle, yeah, it's the middle. The mean here will be bang in the middle. Okay? And the middle of those is like the average of those two things. So it is A plus B divided by 2. So I'm going to call that one of the red box rules. That is the mean. Only applies though to the uniform distribution, the rectangular distribution. Then the variance. There's also a shortcut for the variance for this distribution as well. If we were going to do it normally, what is the normal formula we use for the variance of a continuous random variable? In terms of ease, expectation of things. If we called the mean the expectation of x, can anybody remember how we got the variance? You've got a book there. Can you look back, see if you can find it? You can't find it in your book. You're not highlighting key stuff as you go.
X squared f of x minus e squared.
Yeah, the expectation of x squared. Take away the expectation of x all squared. Yeah, that ties in with what you said. Okay, that is this thing here. Okay, don't write the rest of this bit down. Don't even write that bit down if you haven't done already. Okay, if we did it here, the expectation of x is this integral here. It's the integral of x squared times by that thing. I've just taken that out through the integral sign because it's just number. And you can do that integral. You can substitute things in, and you get this thing down here. Then what you would have to do if you have the expectation of x squared is, well, the variance is the expectation of x squared, take away the expectation of x all squared, which gives you that. And if you then wanted to plot through all the rest of that algebra, and multiplying it all out and simplifying it, you get down to this thing over here, which actually says b minus a all squared over 12. And that is a result you can just quote. And again, it only works for the variance of the rectangular distribution, the uniform distribution, but you can just quote that result. rather than doing the integrating stuff, but it only works for the rectangular distribution. Okay?